Welcome to SP12 part B. The lecture was interrupted in between. So we are studying Markov process, in which we know that the present is independent of past except the latest event, and is independent. Xn plus 1 is independent of whatever is happening at xn plus 1 is dependent only on whatever has happened on n, and is independent of all the events that happened before that. Right. A Markov process, this means that if we draw the same timeline, Tn is dependent on this. T1, T2 is dependent on T1, T3 is dependent on T2, Tn is dependent on Tn minus 1. This is also called first order Markov process, because present depends on just one previous event. Right. Markov process is governed by some distribution of some probabilities that are described in the form of a matrix or a chain. Suppose we have different state is the effect of past on future. For example, if we have state 1 and we want the probability, suppose we have two states A and B, and at time t1 I am at state A. So what is the probability that I'll be at state A or will move to state B? Similarly, if at t1 the process is at state B, there will be some probability that will remain at B, and with some probability it will go to A. So this whole process, Markov process, is governed by a chain. This can also be represented in the form of a matrix. We will see in next lecture. This chain depends on, this chain is called Markov chain and is composed of states and links. There are states. Fortunately, we will study Markov processes with finite number of states in this course. This means these states are finite and there are some link probabilities. If the process is at state A at time t1, at time t2, it will either be at state A or will move to state B, but with some probability. Right. So number of states can be finite, can be 2, 3, 4, but there will be finite number of states, and there will be link probabilities associated with each link. Moreover, the total probability associated with any of the state I is probability P from state I to state J in general, for J being all possible states in the Markov chain, is 1. This means for all I. S. This means where S is the state space containing all the states in the Markov chain. Here in this case we have only 2, but can be more. So S is the state space, whereas probability of Ij is that probability of xn plus 1 is j, given the probability of the last event was I. So Pij is summation for all possible states for all. This also means that this simply means that the sum of probabilities associated with all outgoing links from any state is of 1. This means that if for A the probability in the next time interval I'll be at A, maybe if this is 0.4, this has to be 0.6, so that the sum becomes 1. So if this is 0.5, this also has to be 0.5, so the sum of the all outgoing arrows is of 1. And we have already studied that the first order Markov process gives us probability of Ij, probability of xn plus 1 is equal to a j, given xn is equal to in, xn minus 1 is having some value I minus 1, xn minus 2 having value I minus 2, and x0 having value I0, can be written as probability of xn plus 1 having value j, given xn having value I, right. So all it's independent of all these previous values and is dependent on the most recent value. This we also represent with small p with subscripts ij. In our next lecture, we'll talk about Markov chain in a bit more detail, and we'll see how these probabilities can be arranged in the form of a matrix, and we'll solve a numerical example. Thank you.